Welcome to the Durham York Energy Centre, an energy from waste facility, jointly owned by Durham Region and York Region, supporting sustainable waste management. Each year, the DYEC processes 140,000 tons of residential waste, your household garbage, that remains after maximizing diversion efforts including rethink, reduce, reuse, recycle, and organics recovery. Rather than burying this waste in landfills, we convert it into energy. Using proven technology with advanced pollution control systems, the facility decreases the amount of waste requiring landfill disposal by up to 90%, reduces greenhouse gas emissions, and complies with stringent environmental standards. It all begins at your home, where waste is collected at the curb, transported to a transfer station, and reloaded onto larger transport trucks. These trucks then deliver the waste to the Durham York Energy Centre for processing. Once they arrive on site, the first stop is the scale house. Here, trucks are weighed as they enter and exit the facility. This ensures accurate tracking of all materials and allows the facility to record exactly how much waste is delivered. Each scale is equipped with radiation detectors to ensure that no radioactive material enters the facility. Approximately 20 trucks deliver up to 600 tons of waste per day, 5 days per week. In addition, roughly 8 trucks per day deliver supplies and haul away ash and recyclable metals. Once weighed, the waste delivery trucks proceed to the tipping hall. Before entering, trucks wait outside the closed doors until they are permitted to enter, as the doors remain shut to maintain negative air pressure. Inside, air from the tipping floor is drawn through large fans and used in the combustion process, helping to contain any dust or odors. Once inside, trucks unload their contents, up to 35 tons of waste at a time, either directly into a large concrete storage pit or onto the floor for inspection. An operator using a front-end loader manages waste deliveries and pushes the waste into the pit, where it is prepared for the next step in the process. The waste storage pit, where up to 3,000 tons of waste can be stored at a time, extends approximately 8 meters into the ground. An operator using a grapple attached to an overhead crane mixes and fluffs the waste to make it as uniform as possible, creating a consistent fuel for efficient combustion. Once the waste is properly mixed, the crane operator loads it into hoppers that lead to 2 separate combustion chambers. Up to 18 tons of waste are fed into the hoppers every hour. From here, the waste moves down the hoppers onto the feed tables and begins its transformation into fuel. Now this is where the operation really heats up. From the feed tables, hydraulic rams push the waste onto stoker grates, where it is combusted at extremely high temperatures, in excess of 1,000 degrees Celsius. As it moves along the grates, the system continuously stokes and agitates the waste to keep it moving and to maintain a steady, even combustion. The process is closely controlled using a combination of automated and manual systems that manage the overall conditions inside the chambers, keeping the operation stable and ensuring the waste is fully combusted. Heat and gases released from the process travel through the boilers, converting the water held within the boiler's steel tube walls into high-pressure steam. Once superheated, the steam is conveyed through pipes to a steam turbine generator. As the high-pressure steam passes through the turbine, it spins the internal blades at extremely high speeds. This rotation drives the generator, converting the steam's energy into electricity. Once electricity is generated, it is transferred from the turbine to the switchyard for distribution. In the switchyard, electricity produced by the generator is fed directly into the local electrical grid. Large transformers increase the voltage, allowing the electricity to be transmitted efficiently over long distances. Overall, the facility generates up to 17.5 megawatts of continuous baseload energy. A small portion of the energy is used in-house to power the operation of the facility, while the rest is delivered to the community, enough to power over 10,000 homes each year. After the steam is passed through the turbine, it moves to the next stage of the process, where large axial fans draw in ambient air to cool the steam and condense it back into water. The condensed water is then returned to the boilers and reused in the process. This system saves significant amounts of water compared to wet cooling systems and reduces the facility's environmental impact. The Durham York Energy Centre is a zero wastewater discharge facility, meaning that all processed water is reused internally. Only the facility's restrooms and kitchenettes are connected to the municipal sewer system. In addition to recycling its processed water, the facility also manages another important output from the combustion process: flue gas. The DYEC is equipped with advanced air pollution control and monitoring systems to treat flue gas produced during waste combustion. As the flue gas exits the boilers, it passes through multiple treatment stages designed to reduce emissions and manage a broad range of byproducts generated during the combustion process, supporting safe and reliable facility operations. Nitrogen oxides are controlled first through stage combustion using a very low NOx system, followed by ammonia injection in a selective non-catalytic reduction process for further NOx reduction. Next, the flue gas is treated in a dry, recirculating scrubber system, where hydrated lime and activated carbon are injected to capture acid gases, dioxins and furans, and heavy metals. The flue gas then enters a baghouse that employs thousands of filter bags to capture any remaining particulate matter. Together, these advanced systems reduce emissions to levels that are fully protective of human health and the environment. Real-time emissions data is publicly available both online and on a large visual display board on site, giving residents clear insight into the facility's performance and environmental compliance. The combustion process also generates additional residual materials, including bottom ash, recovered metals, and fly ash. Together, these materials represent approximately 10% of the original volume of waste received at the facility. Bottom ash and recovered metals are conveyed to the residual materials building, where large pieces of metal are first removed. The remaining material passes through a large rotating drum magnet, where ferrous metals, such as iron and steel, are separated and collected. Next, an eddy current separator propels and collects non-ferrous metals, such as aluminum and copper. Approximately 3,500 tons of metal are recovered and recycled each year, enough to build approximately 3,000 cars. After metal separation, the bottom ash requires no further treatment. The fly ash travels to the residual materials building on a separate conveyor, where it is mixed with cement and pozzolan to stabilize the material and render it non-hazardous. Once treated, both bottom ash and fly ash are beneficially reused at landfills as alternative daily cover. Throughout the entire process, operators in the control room monitor and manage all facility systems in real time. Operating 24 hours a day, 7 days a week, the control room serves as the facility's central operations and communications hub. Using advanced technology and software, highly trained provincially licensed operators monitor and adjust every stage of the process, from combustion and steam flow to air pollution control systems and residual material processes. Control room operators also closely monitor emissions through a real-time continuous emissions monitoring system, which provides the information needed to maintain compliance with strict environmental standards. This centralized oversight of end-to-end operations ensures safe, reliable, and environmentally responsible operations. The Durham York Energy Centre plays a key role in our integrated waste management systems by converting non-recyclable waste into electricity, significantly decreasing the volume of material sent to landfill, and reducing greenhouse gas emissions. This work reflects the region's strategic plan goals, making better use of resources, protecting air and water, and planning for a healthier, more resilient community. Learn more at durham.ca/waste.